Hi, thanks for coming to our symposium. I'm really excited to have this group of wonderful speakers together. I'll give the first talk, and then we'll hear from Gus Skorberg, and we're both in person. And then Dan Hendricks and Zhijing Jin will give virtual talks, and then Katherine Heller is here in person, and she'll lead a discussion amongst the panelists, and at that point, we'll also take questions from the audience for the entire panel. But after each of the talks, there'll be time, about 5 minutes for individual questions. Okay. So we're starting a little bit late, so we'll be about 8 minutes delayed in the timing. One of the most striking and important features of the moral mind is its flexibility. We can make moral judgments about cases that we've never seen before. Is it morally permissible to get a haircut during a global pandemic? Before last year, none of us had ever considered this question. And there doesn't need to be a pandemic for the moral landscape to change. The moral world changes all the time. There are new technologies, new information, new opportunities, and we have to make decisions about how to act in the face of these changes. Is there a way to equip AI systems with a moral sense that is human-like in its flexibility? That is, how can we get AI systems to respond in a human-like way in cases that it's never seen before? Now, getting AI to behave in a way that's reasonable in novel contexts is a problem for lots of domains of AI development, not just morality. But I'm interested in thinking about how there might be particular solutions to this challenge that the human moral mind uses that might be important for developing morally competent AI systems. And so the way that I've been thinking about tackling this problem, my general approach to this matter, is thinking about ethics in computational terms. So in order to understand why I think that this idea might be so powerful, I want to take a super quick tour into machine vision, actually, and then we'll come back to ethics. Okay, so the first thing I want to point out is just that machine vision is actually pretty good. We now have machines that can detect whether a skin cancer is malignant or benign, can detect street signs in naturalistic settings, and can classify objects into 1,000 categories at better than human performance. Obviously, there are important limitations to machine vision. So an AI, for instance, that's trained to detect skin cancer is generally hopeless at street signs, but that's not true of a dermatologist, who obviously is also trained to detect skin cancer. But still, machine vision is pretty good. So how did machines get so good at seeing? Part of the story has to do with David Marr. So Marr was a vision scientist, and one of the central ideas that he had revolutionized the way that we think about and study vision. Marr's big idea was to think about vision as computation. And Marr thought about computation as information processing. So vision is essentially an information processing system that maps some kind of information and input onto another set of information and output. And there's a sense in which Marr thought that it didn't even matter exactly how this transformation was happening. Like, it didn't entirely matter what was going on in this black box here. But the first thing to figure out was what transformation was happening at all. So what input is being systematically transformed into what output? For instance, this equation describes the visual control system of a fly. It converts an input that the fly obtains from its visual system to an output, here a motor response, like orienting. Now, this sort of thing, this kind of mathematical equation, is what we're striving for when I'm trying to describe a cognitive system in computational terms. Okay, so why was Marr's big idea, the idea that vision is computation, so powerful? Well, it turns out that once we saw human vision as an information processing task, then we could harness the advances made in artificial intelligence research at the time. A new world of information processing tools suddenly became available to help us study and understand human vision. Meanwhile, as we started to describe human vision more accurately, we could develop better machine vision. And as machine vision got better, we developed additional hypotheses about how human vision might work. And this positive feedback cycle basically continues to this day, making machine vision one of the most advanced areas of AI research. Now, the key to all of this was the insight that we could understand vision in computational terms. So what I'm trying to do in my research program is to see ethics as computation and to describe ethics in computational terms, attempting to create a similar kind of positive feedback loop. So what I'd like to do now is just illustrate what I mean when I say that our goal is to describe ethics or moral cognition in computational terms by way of giving a lightning-fast summary of a recent paper of mine, so you can kind of see how this works. Okay, so consider the following case. The people who live in this village have been fishing sustainably in this lake with this traditional fishing method for a long time, but all of a sudden the local tackle shop in town starts stocking a new kind of fishing hook, which is much more powerful than the old fishing hook, and you can collect many more fish with this fishing hook than you could with the old one. But there's a wrinkle to this story, and that's that a certain number of people can use the new fishing hook with absolutely no negative impact on the fish population. So this is the number of people using the new hook. But eventually, once a certain number of people start using the new hook, then utility quickly drops off, and eventually the fish population goes extinct. And that would be bad for everybody involved. So the question that we're going to be asking when we manipulate various features of this story is, what is the probability that our subjects will say that one person using this new fishing hook is morally acceptable? So our suggestion in the paper is that people answer this question by using the logic of universalization, that is, by asking, what if everyone felt at liberty to do that? So the goal here is not just to determine whether or not people are using the mechanism, but to characterize the mechanism as a series of computable steps and to ultimately be able to define an input-output mapping. So this is our sense of what the computational mechanism of universalization is like. So first people ask, what if everyone felt at liberty to do that? Do something specific, like use this new fishing hook. And then they assume, well, if everyone felt at liberty, then the people who are actually interested in doing the thing would actually go ahead and do it. Well, then they observe, well, how many people actually are interested in doing the thing? And then they calculate, well, if all the interested people went ahead and did it, what would the global effects be? What would the utility consequences of those people doing it be? And then they transform that utility judgment in a fairly straightforward way into a moral judgment. So you can see that each step of this process is a computation that can be performed simply by gathering facts about the situation. It's just information processing. And the key here is going to be to probe and characterize each of these steps. So the first thing we set out to do is just to see if there's a certain kind of expected relationship between one of the early steps and one of the later ones. That is, the first thing is just to see if there's a relationship between the number of interested parties and moral judgments. Okay, so here's what we do. In one scenario, we told our subjects that everyone in this village was interested in using this new fishing hook, but that they all decided not to because they didn't want the fish population to go extinct. And we ask our subjects to make a moral acceptability judgment about this just one person who's still considering using the new hook. And so if people are using universalization, they ask, well, what if everyone felt at liberty to do that? Well, then all the interested parties would do it. Everybody is interested, everyone would do it, and that would be bad. So universalizing yields the judgment that it's not morally permissible, even for just this one person to do it. We contrast that with a low interest condition. That is, nobody in the village is interested in using this new hook. They already catch enough fish, they don't need any more. So they all decide to not use the new hook. And again, we ask our subjects to make a moral judgment about this one person who's still considering using it. And if subjects are universalizing, they'll ask, well, what if everybody felt at liberty? Then nobody would do it because nobody's interested. And so it should be perfectly fine for just this one person to use the new hook. And just as we would expect if people are using universalization, we see this characteristic difference between the conditions. It's more morally acceptable in the low interest case as compared to the high interest case when people are making judgments in this scenario. Okay. But what we do then next is to dig into each of these steps of the computational mechanism, and we do a series of studies where we manipulate, for instance, the exact number of people who are interested in using this new hook. So rather than just everybody or nobody being interested, we ask, what if 2 people or 8 people or 19 people are interested in using this new hook? And we're able to predict our subjects' judgments with a kind of fine-grained accuracy. And then, in fact, we can do even better if we incorporate our subjects' understanding of the factual elements of the case by moving on to the next step. For instance, we can ask them to estimate exactly what would happen if certain numbers of people use the new hooks, and we can get an even more fine-grained estimates of our subjects' judgments by doing that. So in the end, we can write down this algorithm that translates an input, namely information about how many people are interested in doing an action and the utility consequences of those people acting, into an output, that is, a moral acceptability judgment. And this is the kind of thing that in general I'm going for, a computational account of one of the mechanisms behind human moral judgment. So at this point, I want to bring us back to the question that we started with. How can we create AI systems with a flexible moral sense? And one of the reasons that I was interested in universalization as a mechanism in particular is that I think it might be the key to understanding the flexibility of the human moral mind. So in general, the human moral mind uses rules to make moral judgments, and rules are often thought of as rigid. But there's actually an endless number of exceptions to rules. It's wrong to lie, but actually white lies might be okay. It's wrong to steal, but it might be okay to steal a napkin from a cafe if you have a bloody nose, and on and on. So how do we figure out when it's okay to break the rules? Where does this kind of moral flexibility come from? And I think the answer to this question is that we have generative mechanisms that produce these rules in the first place, and we can use those mechanisms, we can access those mechanisms to update and change the rules. And I think universalization is one of these generative mechanisms. So just to play out a little bit how I think that works, the trouble in the fishing village starts when a new hook appears and the old rules don't apply. So by asking, what if everybody felt at liberty to do that, people are essentially asking, what new rule should govern the case? What new rule should govern the use of this hook? So universalization might help create novel rules in these novel circumstances that don't have rules to govern them yet. On the other hand, once a rule has been established, such as don't use the new fishing hook, for instance, universalization helps us figure out when the rule can be overridden in an unusual or a novel circumstance. Say, one particular person has a special need for more fish. Then we might ask, well, what would happen if everybody in this circumstance broke the rule? Would that leave us all better off? Or would that ultimately undermine the purpose of the rule in the first place? So universalization also helps us figure out when it's okay to break the rules. Understanding the role of universalization in the moral mind might help us understand our ultimate moral flexibility. And so understanding how this works in computational terms could be critical to building AI systems with a human-like, flexible moral sense. Okay, so my collaborators and I have a whole series of papers, some of which are out, some of which are in progress, looking at this idea. If you're interested in this, I'd recommend you to see a talk by my collaborator, Joe Kwan, who's giving a talk tomorrow. And Zhijing Jin, my collaborator, will give a talk on some of these extensions, particularly in the domain of AI and natural language processing in just a couple of minutes. So stay tuned to that. But I would want to say one final thing about the relationship between human ethics and machine ethics. All this time I've been saying how developing a computational theory of ethics will kind of help or inspire machine ethics in some way. But it's important to remember that the process of describing human ethics will sometimes reveal the fact that humans make bad moral decisions. They can be biased, they can be inconsistent, for instance. And so in this process of thinking about how human ethics and machine ethics can be in dynamic exchange with one another, we also have to incorporate normative ethics to figure out what kind of ethical judgments we want our AI systems to be making. And that's actually something that Gus Skorberg, the next speaker, will speak about in more detail. So thanks so much. There's time for a question or two. Before I do that, I just wanted to give a quick pitch. So currently, I'm a postdoc at Harvard and MIT, but I'm about to start a new position at the Allen Institute for AI. And typically, they're a group of folks who are trained in computer science, but I'm a cognitive scientist, and I'm about to join them, and I'll be looking for students, graduate student interns and pre-docs, and they have great postdoc opportunities also. So if this is something that is potentially of interest to you or a student, definitely feel free to get in touch. Are there any questions?
Yeah. Yes. Thank you for a very interesting talk. My question is inspired by moral philosophy. As you probably know, there are these three major theories. One is utilitarianism, and you took it for granted. You didn't even bother to say, I use utility as the North Star of morality. But there is also deontological ethics, and then there is virtue ethics. Let's not worry about virtue ethics. But Immanuel Kant is the major philosopher with the ideas of duty and things, and many of these terms that you use, universalization, be your own legislator, what would happen if what I'm about to do becomes the universal norm, is actually something that comes more from the deontological tradition rather than utilitarianism. And so I find it very interesting. You took utility as a premise, but then you talk about universalization and all of that. What are your thoughts, and have you noticed this connection before? And I'm sure you have a lot to say.
No, thank you so much for the question. Yeah, so I've thought a lot actually about the intersections of the various kind of major views of moral philosophy. So you bring up deontology, which is typically thought of as this rule-based approach or constraints on actions, utilitarianism, which thinks about utilities, outcomes, costs, and benefits. And I actually think of the third major view of moral philosophy as contractualism. Virtue ethics, as you say, we don't need to think about that. But contractualists are concerned with agreements between parties and how that might help us make moral judgments. And so you're right that often universalization is associated with Kantianism, but in fact universalization appears in all of the major views of moral philosophy. So R.M. Hare, for instance, who's a rule consequentialist, thought that universalization was one of the most important tools that we have for making moral judgments. And Scanlon, who's a contractualist, uses universalization in his view as well. So I think of universalization actually not as assuming utilities and not necessarily exclusively associated with the Kantian tradition, but actually as a mechanism that we find in all of these methods of moral philosophy, indicating that it seems like it sits at the intersection of all of these views, potentially suggesting that it's both core to our kinds of like ways of moral thinking, but also potentially connected to something really normatively important as well. And so that's why I'm centrally concerned with that view. Now, you're right that utilities kind of play an important role in this model, but they're not the end-all and be-all of what we need to make a moral judgment. They're relevant for moral judgments, which is something that maybe Kant would have objected to, but we don't. What the view is not is just a simple summing of utilities to get the correct answer to our moral questions. But utilities are involved in the further computations that we then go on to do. So yeah, thanks so much for that question. I'll also just say that my collaborators and I are currently working on a theory piece where we're trying to integrate these various views of moral philosophy and explain how there is a view of moral psychology that also integrates these three major theories as well. Any other questions?
Thank you. This is fascinating. I'm actually interested in the data that you're gathering in order to try and derive some of these equations. How would we balance the fact that these equations won't just reflect, tendencies of college students or people with access to internet or whatever it might be?
Yeah, thanks so much for that question. So right now, we can't really, so all of these conclusions should be taken with that caveat. The one exception is that we have a series of really wonderful developmental studies that were done with young children ages 4 to 11, so that provides at least some diversity across age ranges, suggesting that there are very young kids who have not taken Kantian ethics courses in college who share some of these intuitions. But I'm about to start on a more extensive cross-cultural study, and I'm not sure what I'll find. And maybe I'll find that this kind of mechanism is kind of constrained to Western liberal democratic thought. I suspect that using the certain kinds of manipulations that we have, we'll be able to detect this much more widely, but of course that's an empirical question. Thanks so much. Okay, so we'll just move on to the next speaker.
So much. Let me show the slides. Can people see the slides and also hear me? Great. Awesome. So hi, everyone. I'm Zhijing Jin. Today, my talk will be about when to make exceptions, exploring language models as accounts of human moral judgment. To put this talk in context of our symposium, so far we have covered insights from the side of cognitive science, and also there are discussions about contractualism and also cases where moral judgment will for sure be important for future AI, and also the sort of future direction looking into moral parliaments. But for my talk, we will specifically focus on among all these frameworks, what can be the role of language models in this case, specifically with the rise of GPT, BERT, and many other transformer-based natural language processing models. And I'm a PhD at Max Planck Institute and ETH. And today, my talk will be based on our recent paper on this topic. And we have a collaboration team of diverse expertise, which is also what we believe as the golden approach for tackling ethics and AI. So in our team, we have members expertise in cognitive science and more psychology, natural language processing folks, and also machine learning, causal inference people. And so now let's dive into today's talk. For our work, we specifically tackle the case when models will make moral exceptions. And our motivation is that humans keep making exceptions all the time. So we can put a simple example of don't cut in line, which is the commonly accepted rule. But when we are actually waiting in line, it's actually also perfectly acceptable if we see maybe a mom with a kid in help. Then at least in my case, I would of course, go ahead, let that person in the line. So moreover, in our work, we actually gather a rich list of different exceptions people make. It could also be people rushing for flights, people need medical help, and so on. And we compile hundreds of scenarios from previous work of Sydney on moral judgments. And then to contextualize our work a little bit better, there could be multiple questions to tackle for AI ethics. And then the specific use scenario that we see immediately helpful will be in the very near future, or even now, there are AI systems doing various tasks, maybe accepting a lot of customer service requests. And in most of the AI systems, there's always tricky scenarios, like which customer to prioritize and what exceptions to make. So learning about exceptions is not just like in the typical scenario where we explicitly ask AI to give suggestion for the next action, but in any decision that an AI system make, even currently, we will need this. And the specific scenario that we want to avoid is models that will take humans, like humans command, like previous command, maybe a person setting a rule to the robot about don't allow cutting line. We want to avoid the case where robots take any command too literally, and that will most of the case result in, like, at least in many worst case scenario, that might cause a lot of caveats when there are important exceptions to make. So, and the root of the problem here is about, like, whenever human is specifying any command to a language robot or household robot or any AI assistant, like humans, specification is usually imperfect and incomplete. It's not a formal justification that is verified. And then, like, also for humans, we have cognitive difficulties specifying everything and listing out the numerous exceptions of a rule. So what we do, building on top of the work in previous of previous speakers, is that we identify that there could be two directions, two dimensions in how we try to make AI models do more moral question answering scenarios. So if we base on the previous work by Dan in the ethics data set, where there are a number of common sense moral scenarios, and then how acceptable they are and various analysis. So one obvious direction is to cover more common sense scenarios so that the future AI could be more comprehensive when seeing when seeing like various scenarios. And then the other direction that this work with Sydney we want to address is, are we able to extend towards another direction to make sure that even for each single norm, we would know how to make exceptions, and many of the cases, each rule could be like more than hundreds of exceptions. And then with this goal in mind, we propose this data set of rule-breaking question answering, which is under review this year. And in addition to the data set, we also use it to analyze the what's the best way to use the language models address these questions. So how we set up the language model is that we try to trigger some chain of thought behavior when it answers moral questions. So a typical scenario for the normal use of language models is that people put in a prompt describing the scenario. In this case, like we take one of the cuts the line exception case. Imagine 5 people are waiting in line to use a single occupancy bathroom. Someone arrives who needs to clean the bathroom. In this case, is it okay to allow this person cut in the line? So when we query the actual language model, like the GPT-3 instruct model, state-of-the-art one for now, about this scenario, the answer we got is similar in the spirit of the model understands there's a rule that people should not cut in line. And then like they would say like, in this case, no. But this type of answer is not what we want, especially for the exception case, or not necessarily it should sort of like recall the rule and just say no. What we do is that we want to break the direct question to sub-questions that carry spirit of moral psychology in it. Some of the questions we ask with a spirit of contractualism is, what is the purpose of this rule to not let people cut the line? And then also like, if we break the rule, who will be harmed by how much, who will benefit by how much? So these sub-questions have some utilitarian spirit in it. So we have a pool of these sub-questions. And then So we sort of like ask AI these sub questions before finally ask, now, given all these thinking, is it okay to allow this person cut the line? And then like in many of the scenarios, we observe that the AI has increased moral flexibility towards rule-breaking scenarios. And then like we conducted the entire study on the latest language model, Instruct GPT by OpenAI. And so the main spirit is to design a series of morally inspired sub-questions and let the model answer the sub-questions before asking the final one. And using this moral psychology inspired model, we call it moral chain of thought, COT, and we achieved almost 9% F1 increase over the previous, at least on this data set, the previous best performing model, Delphi. And then, so with this spirit, this is an outline of our sort of preliminary exploration into analyzing language models on rule-breaking moral questions and also exploring some improvement over that. In the long run, the next steps we care about include two directions. One is that we want to enlarge the width and depth of the explorations. There are two different goals again here. One is that we want to deepen our understanding about how humans make exceptions and how institutes should decide about exceptions, which is like sort of precursed by this work. And then the other goal is to extend to more different rule-breaking scenarios to understand, like to cover a more comprehensive list of common sense scenarios. And then we would also be interested in whether there would be a multi-pass moral COT, as is already pointed out in previous question answering. There could be different series of moral philosophy. And then would it be possible to learn how these interact with each other and lead to the overall judgment? And there could be questions on individual level and society level. Great. So this is the end of my talk. And we could either take questions now or just put every question into our symposium so that Sydney and I can both answer the question in an interactive way. But either way is fine. Thanks.
Hey, okay, so this is a question online from Michael Cooper. One common way that we make exceptions to moral rules is to say that breaking the rule serves the common good, consequentialism. This is problematic because the task of determining the common good in the future involves complex world modeling to predict outcomes. Do you think it's possible to mimic this process without world modeling?
I think this is a great question. Also linking to some of the challenges mentioned in Dan's talk. In order to make a moral judgment based on consequentialism, it's very crucial to have as accurate forecasting or like utility evaluation model there. And my personal stand on this question is we will have to have a good enough word modeling to do it, because at least the current way that language models learn things is still largely based on like what it see on all the internet corpus. And a lot of theories say like it's mainly capturing word co-occurrences or just like many complicated combination of like words. So here I would stand at the point that more accurate word modeling or even one more breakthrough of prediction models, forecasting models, these are essential for such moral decisions.
Okay, great. Thanks so much, Zhijing. And our final speaker will be a discussant, Katherine Heller.
Okay, so I'm trying to juggle reading the text questions and doing this at the same time, so I'm sorry if anybody gets left out. I think that one of my goals really in this sort of discussion section is to try to get people in the audience to ask questions and to think a little bit about sort of what we've heard overall. And I think it's really important kind of going forward because a lot of these questions around ethics really play out. I'm at Google, right? I'm at a tech company, and they really play out in terms of sort of where technology is going and how we get our values into the technology that we have, and that is a really, really big issue, and one that sort of arises for me. I'm in responsible AI at Google every day, and so it's very important to be able to hear from this community and to hear from people in general how we do this, because it definitely needs to happen. Okay, so some common themes in what we heard. Going to like sort of like is versus ought. That was like a common theme that came up a lot, modeling things that people actually think right now versus like some idealized version of what they ought to be. Again, this is like a tech-heavy question right now, right? Should we be sort of like when we give suggestions in terms of search results or in terms of YouTube video suggestions, should we be reflecting kind of what people want to see right now, or should we be reflecting some underlying societal value with the suggestions that we make? Another common theme that we heard about was rule breaking. So like, you know, saying, okay, there's some rule, everybody typically thinks that that's true, but like there are exceptions to be made to that rule. And the last one was large language models, which I work with a lot. And again, how to incorporate some of these values into large language model settings. Okay, so first, is versus ought. So the is, what are our currently held values? Ought, what should our values be? I think that this was a very sort of almost contentious topic of conversation. And so I'd definitely be curious in hearing sort of more thoughts about when it is that we want to incorporate currently held values versus idealized values into various aspects of society. One of the things that I think that wasn't discussed so much, though maybe it was and thought not to be of value right now in people's presentations, was the including of cultural context or various different sort of opinions about what the is. And I personally do a lot of work every day that takes different people's perspectives into account, or tries to take different people's perspectives into account. And so for me, this is a very sort of like salient and important question. And particularly with respect to people who come from different places, or the inclusion of different minority voices even within the same place. So one of the people who I work with does a lot of work much along the same lines of as some of the presentations that you saw here using large language models like GPT-3 in order to look at values. But they do it in the sense of like values across the world, right? So one of the things they do is they look at the World Values Survey, and they here I have sort of like the map of where everybody's values in different countries or regions fits into various axes. In terms of what their beliefs are, and looks at that. And I think their paper, the name of the person on my team is Beck Johnson, and the paper is something like "The Ghost in the Machine Has an American Accent," right? So you can see that where the people making the value judgments are coming from actually impacts the judgment that they make. And this is particularly relevant with things like GPT-3 and large language models because so much of our data is English language data, right? We tend to really, really be overrepresenting right now all of the English language spoken values, right? And so how is it that we go about incorporating a larger diversity of values into that? Okay, so what's popular is not always right. So this is an important thing, right? So this is like a justification for the ought again, right? Just because something is like liked by a lot of people, just because you get a click-through rate that's high, doesn't necessarily mean that it's the correct thing to show people, right? And that's an issue that we come across a lot. Rule breaking and uncertainty, I think for this one, as a Bayesian, right, I guess I never think that anything like any rule is true all of the time. It's 100% true all the time. And so I guess my thought here was something like wondering if a probabilistic perspective or framework can help us think about rules and rule breaking, and certainly comparing them across different regions. Large language models, when in the large language model do we want to reflect the is, the way things are, versus the ought, the way things should be? How do we reflect different cultural values? How do we incorporate value structures into large language model results? This kind of relates to causality. Can we come up with a causal framework for being able to include some of these values into large language frameworks, right? So one of the things I think a lot about is what's the pragmatics of this incorporation going to be like, right? Can we construct something like a causal graph that can mimic our values in some way that we can use within the context of a large language model? And lastly, AI regulation. This is like a big issue. So the questions about how is AI best regulated? How is it that we are most likely to be able to see values that we hold incorporated into some of the things that we see coming about in a natural language processing context right now? What are the best things to be implemented internally for tech companies or externally for governments? And then again, what are the rules that are going to most pragmatically get us someplace good? How are legal considerations taken into account? So again, lots of questions, and I'd be curious in hearing some of yours. I think so would the people who have spoken.